So let's take a moment to talk a bit more about the A in mean, AngularJS, and managing the client. Before we can talk about Angular, though, we need to establish a couple of facts about web browsers in general, normally the client side of the client-server relationship when we're talking about the Internet. Remember how we said that Node is written in C++ and the V8 JavaScript engine and most JavaScript engines, in fact, are written in C++. Well, here's another thing to know. For the most part, browsers are written in C++. Google Chrome, Firefox, popular browsers are written in C++. And while only Google Chrome uses the V8 engine, in general, browsers also have JavaScript engines embedded in them and give those engines access to features beyond what the JavaScript specification says JavaScript should be able to do. Now, that might sound a bit like what Node.js does, and you're right, it's the same idea. A program with the JavaScript engine embedded in it that does more than just what the JavaScript engine does. However, the browser is installed on the client, the computer of the person that's using that particular web page. So the server just has Node.js installed, but each individual client will generally have a browser. Now, what happens when the browser receives the text as a result of the HTTP request for a web page? Well, we've already generated HTML using a template engine and Express. But what happens when the browser actually receives that string of text? How does it break it down and know how to then translate that HTML into something that's visible, the web page that you can see? Well, that has to do with something called the DOM. Big word alert. The DOM. This is the structure that browsers use internally, generally collection of C++ objects to store and manage web pages. DOM stands for the Document Object Model, and browsers give the JavaScript engine the ability to manipulate the DOM. This is often a misunderstanding with web developers. The DOM doesn't live inside the JavaScript engine, really. The browser uses the DOM to render the web page and gives JavaScript access to the DOM, gives it features so that it can manipulate the DOM under the hood. And when the DOM is changed, then the browser will automatically regenerate, recreate, re-render the web page. And this is the basis for modern web applications. So how does this work? Well, the browser is a program sitting on the client's computer, and it receives some HTML as the result of an HTTP request. So the HTTP response body contains the HTML. We've seen this. We've tried doing this in Node.js using Express, and we're really just building a string and then sending it back as part of the HTTP response. But now the browser needs to take this string and decide what to do with it. So it actually doesn't just use this string all the time. It really just processes the string once and builds the DOM, the Document Object Model. And it takes that HTML and converts it into a hierarchy of objects, which represent the various HTML elements. And it becomes the DOM tree. Now, this idea really fits well with HTML itself, because HTML is really a sequence of elements with children and grandchildren, etc., and sibling elements. So HTML itself is structured in a tree-like fashion, and so translates really well into a tree structure like the DOM. And the browser then renders the web page using the DOM, not using the string that it was given to build the DOM. And then also embedded within the browser is a JavaScript engine. Now, if it's Chrome, then V8 is embedded. The same engine as Node.js, but if you're using a different browser, then it's a different engine. But the concept is still that it's executing the JavaScript you get it. Now, in the browser's case, JavaScript will sit inside a script tag, or a script tag will be a reference to a .js file. In either way, the browser will pass the contents of that JavaScript to the engine and run it. And so it will receive it and execute it. And this again is happening inside the browser. We're not talking about Node.js here. And then the JavaScript engine, if that JavaScript code contains some of the extra features to manipulate the DOM, then the code that the JavaScript engine runs will manipulate the DOM, perhaps adding elements, changing elements, removing elements. And when that occurs, the browser will re-render the web page. It will update, reflow, move around things. It will do things dynamically. You click a button and something appears or disappears. That's because when you click that button, the browser caused some JavaScript code to run, to be processed through the engine. And that code contains some references to features that, while they don't exist in core JavaScript, the browser gave JavaScript access to. Ultimately, most likely some C++ code to run that manipulates the DOM. So the JavaScript that was run through the engine actually caused some C++ code to run that manipulates the DOM. The DOM is then changed in some way. Let's say an element is removed or added, and the browser automatically knows that it needs to update how the web page appears. And so things appear or disappear, because that tree underneath that defines how things should appear has changed. Make sense? This is the core of how modern websites and web applications work. JavaScript code running in the browser through the embedded engine, manipulating the DOM, making the web page dynamic, allowing it to change, to respond, thereby making the web page interactive. This is how this works. Now, the problem is that different web browsers can have slightly different JavaScript code that's expected in order to manipulate the DOM. So if you're writing JavaScript code for the browser and you want it to work across many browsers and many versions of browsers, you have to worry about all of the different ways you might have to write your code. You may have to do the same code multiple times in different ways so that it works across many browsers and many versions. That gets really cumbersome. It's also really cumbersome when your application gets very large. Manipulating the DOM, keeping track of what's going on, can result in a whole lot of extra code, of what I like to call just plumbing code. Code that's just there just to handle doing the work rather than thinking more about what the work is that you want to do. And so frameworks, JavaScript frameworks like AngularJS, help us with that. They keep us from having to deal with code for each kind of browser, and they help us structure our applications and keep things manageable. And really all AngularJS is, like other JavaScript frameworks, is just a bunch of JavaScript code that someone else wrote, much like Express. So it's just a bunch of JavaScript code that we are taking advantage of. The browser will load it in through the JavaScript engine, and then we can write some more JavaScript code, taking advantage of all the work inside the JavaScript code of a framework like AngularJS. Now, this course isn't about AngularJS. The focus is on Node.js. And really, AngularJS is a big subject and really is a course unto itself. However, we are going to look at AngularJS from the perspective of the mean stack, but also from the perspective of dealing with JavaScript code on the server and on the client. This is the area where you can begin to get confused. You have JavaScript that's meant for the browser, you have JavaScript that's meant for the server, and they're all sitting inside the same application. So you can start to mix things up in your head and make some core mistakes. So We'll highlight as we go and look at AngularJS the difference between manipulating things in JavaScript on the browser and manipulating things in JavaScript in Node, and making sure we have those two things clear in our minds that will allow you to be successful when coding in something like the mean stack. Now, first of all, let's try actually putting some AngularJS-based JavaScript code down inside our simple Node application.